Okay, here we are, Unit 2, Lesson 3. This will be a nice short lesson today. Hopefully you have printed off the notes. If you haven't, these notes here are on Connect for you to print out to follow along so you don't have to write out as much. So we're just going to go over some parent functions and graphs and just key attributes for that you're going to be looking for. So we'll just kind of start, and we're going to start with some important terms to know and understand. We're going to start with a parent function and what a parent function is. A parent function is a set of that's a little too big. It's a set of basic functions used as building blocks for more complicated functions. So one of the first attributes that we want to talk about is something called continuity. And continuity is a function with a connected graph. And we're going to identify whether each of the function is continuous. So one of the key things about determining whether a graph is continuous or not, if I were to take my pencil and go along this graph right here, if I do not pick up my pencil, it's continuous. So this function would be considered continuous because I didn't have to pick up my pencil. Now when I go to the second graph, I go along here, I have to lift up my pencil and go back up to the top to continue my graph. Now it's a function because it passes the vertical line test, but it's not continuous because I have to pick up my pencil to continue to my graph. And then the last one, I start here, go down, go back up. I don't have to pick up my pencil, so yes, it's continuous. So that's how you identify whether a function is continuous or not. If you have to pick up your pencil, it's not continuous. Now the next attribute we're going to talk about is finding intercepts. We have two intercepts. We have the x-intercept and the y-intercept. The x-intercept is the point at which the graph crosses the x-axis. Okay? And so when I look at this graph, I'm going to look, this is my x-axis, and it looks like the graph crosses here, here, and here. I have 3 x-intercepts. Now when you have an equation, you're going to substitute 0 for y and solve for x. But on a graph, it's really easy to see. It's going to cross in 3 different places. So I want to look for the ordered pair of that. This right here, my ordered pair is going to be -3, 0. This one right here, my ordered pair is going to be 4, 0. This point right here, I'm going to have to do a little bit of estimating because my graph isn't perfect. And so I'm going to estimate that that's about halfway. So I have 1/2, 0. So if you notice, I have an x value and a y value, and the y value is always 0 for my x-intercept. Okay. Now my y-intercept is where the point at which the graph crosses the y-axis. Okay. And again, if you have an equation, you're going to substitute 0 for x, solve for y. Okay, but when I look at the graph, I can look right here. This is where it crosses the y-axis. It only crosses at one place, so I only have one y-intercept. And the ordered pair for that y-intercept would be 0, 2. All right, and if you'll notice, the x value is always 0. The y has a value. All right. Now the next attributes we're going to talk about are local, minimum, and maximum. Or if there's more than one, it's maxima and minima. So the local maximum is the highest point on a graph in a given area. So when I look, I'm going to have right here, I have a high point, and right here, I have a high point. So I've got two different maximums. I would have one at negative 3, 3. That's this point. And then I would have one at 3, 2. That's that point. Okay? And the reason we do two different ones is because my graph it's going up and down. So for this interval this way, this is my maximum. For the interval this way, this is my maximum. All right. The local minimum is going to be the lowest point on a graph in a given area. So here is my lowest point. I only have one. That's my local minimum, and it occurs at 0, negative 4. All right, the next attribute we're going to talk about is increase and intervals of increase and decrease. So when a person is walking uphill, the graph is increasing. When the person is walking downhill, the graph is decreasing. Okay? When the person is on the top or the bottom of the hill, so if I had a person standing right here or right here, they are neither increasing or decreasing. So we use parentheses instead of brackets for interval notation. So we want to look at this graph right here, and we want to identify the intervals of increase and decrease on the graph above. So I'm going to go right here. This at 2 is where they're not increasing or decreasing anymore. And then I'm going to come over here. And at 6, that's where that's the bottom of the hill, and they're not increasing or decreasing anymore. So because we have a maximum point right here at 2 and a minimum point right here at 6, we are going to use parentheses instead of brackets. And I like to use the number line up here. I can see from this number right here, which is 0, to 2, we're increasing. Then from 2 all the way down to here, so from 2 to 6, we're decreasing. And then from 6 up, we're increasing. So 6, and since it doesn't have an end point here, it's going to be infinity. Okay, let me go back over here. This does have an end point right here, so it's going to be increasing from 0 to 2. So I need to use a bracket here because that has an end point. All right, so we want to write our intervals of increase. So it increases from 0 to 2 and 6 to infinity. And then it decreases from the interval of 2 to 6. All right, now we want to look at end behavior. And I think we talked a little bit about end behavior in our last lesson when you were graphing. So we'll kind of continue that and hopefully get a little bit better with that. So end behavior describes what is happening to f of x or y, they're the same thing, as x gets very small, which is negative infinity, or very large, which is positive infinity. So we want to describe the end behavior for the following graphs. So I am looking at as x approaches negative infinity. So as I am going this way on the x-axis, they want to know what is happening to my y values. Are my y values increasing or decreasing? So when I go to negative 1, my y value is up here at 4. When I go to negative 3, my y value is 0. When I go out here to -4, my y value is -4. So if I continue to go out here and pick -5, -10, or -20, or -1,000 for my x value, my y values are going to continue to go down and down and down, so they are going to continue to approach -infinity. Okay. Now we're going to repeat and look at what is happening as my x values are approaching positive infinity. What is happening to my y values? What are they approaching? So I go over here, I go to +1, my y value is a little over 2, or a little over 3, 3.2. I go over to 2, my y value is 3. I go over to 3, my y value is 0. I go over to 4, my y value is -4. So if I go over here to -5, my y value is going to be a negative number. If I go over here to -10 and I go down, my y value is going to be a negative number. My y values are going to start to approach infinity. So as my x values approach infinity, my y values are approaching infinity. All right, let's look at this graph. So this graph is a nice little curve. All right, so I want to know what is happening to x as what is happening as my x values approach infinity. What's happening to my y values? So as I'm going out this way, at first, as I'm going this way, my y values are getting smaller, but then they're increasing, and they're going to continue to increase towards infinity. Now I'm looking at as my x values are approaching positive infinity. So as I'm moving this way, I want to know what is happening to my y values. Well, first, my y values are positive, and then this is my turning point. They start to turn negative, and they're going to continue to go down, 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 and approach infinity. Okay? All right, let's talk about an asymptote. An asymptote is a line that a function approaches but does not touch. So when we're looking at this graph right here, it's not continuous, because as I draw my graph, I draw this, and then I have to lift up my pencil and come back up here and start the next part of a graph. So if you will notice, there is 2 invisible lines. One happens to be the y-axis. My function is getting closer and closer to this y-axis, but it's never going to cross it. And on this side, the function is getting closer and closer to the y-axis, but it's never going to cross it. So the y-axis right here is this is called a vertical asymptote. Okay, and then we also have a horizontal asymptote. All right, so as I'm drawing this equation, it's going to get closer and closer. It's going to approach the y-axis from the negative side, and it's never going to cross it. And then when I go to the other part of the function, it's getting closer and closer to the x-axis, but it's never going to cross it. And it's approaching the x-axis from the positive side. So this is called a horizontal asymptote. All right, and the last key attribute we want to talk about is domain and range. And if you'll remember, the domain is always all the possible x values that can be graphed, and the range is all the y values that get graphed. I feel like that's improper English, but I think that is how you say it. Okay, so this is a short one. Those are all the notes that I have. You are going to use these notes to help you. Your homework is going to be you have 6 functions. You are going to fill out this for each one of the functions. What you are going to do, you're going to take this function right here, f of x equals x, and you are going to fill out this chart right here. So you're going to substitute, for example, you're going to substitute negative 1n for x and find y. So you're going to find f of negative 1, which ends up just being negative 1. Then you're going to follow that for 0, 1, and 2. So when I put in f of 0, I get 0. When I put f of 1, I get 1. When I put f of 2, I get 2. Okay? So you're going to fill in this chart. Then you're going to graph this. I'm going to come over here. I've got a negative 1, 0, 1, 2, and I'm going to draw my graph. Just assume that it goes through those lines. And then I want to go and find every single one of these things. I want to find my domain and range for this function. I want to know, is it continuous or discontinuous? You can circle it. I want to know, is there a maximum or a minimum? And in this one right here, there's not, I'm going to help you out on this one, there's not a maximum or a minimum. So this one doesn't apply. And then you don't want to forget over here, okay, you're going to find in behavior, but you also want to find an x-intercept and a y-intercept. And this one is pretty easy. Right here, the x-intercept crosses at the origin. So my x-intercept is 0, 0. And that's also where my y-intercept is at 0, 0. Okay, so you're going to do that for each of these functions. I think there's 6 of them. And you're going to bring this into class with you tomorrow. So that's all of your notes. And